Okay, so Mirror's Edge. It's another, obviously a lot of people know that we help the DICE folks with physics implementation here. This is another game based on an Unreal Engine. But beyond the physics, in fact, I'm not really going to talk about the physics side of this. Batman is a good example of a physics title and a good engagement. I'm going to talk about a lot of the other things we did, which not a lot of people actually, I think, kind of knew. We spent a good deal of time on performance optimizations. We worked on some image quality improvements, which were just kind of good for everyone. We added anti-aliasing support again. These are all things, again, trying to just make the game better on the PC than on the console. So that's kind of what we did here. So one of the things we did was there's some performance issues that they had that had come redundant copies. So we profiled their code, we found those things, removed all those redundant copies, extract direction, stuff like that. And so these are different build numbers of the game. So we had access to their source trees and build numbers and stuff like that. We wrote the code. And you can see from a performance perspective, this is when we started, this is when we finished. Both ATI and NVIDIA benefit from this work. This is not, we didn't if-def it, there's no special, we made us fast, nothing like that. We just made it better. Right? This is goodness that the whole industry got. We both improved our performance a pretty good bit. Anti-aliasing support, as we mentioned, we implemented that. Again, this is a simpler change, so you can see that ATI gets anti-aliasing without physics, and we get both anti-aliasing, and we get, of course, we implemented support for some of our special features like CSAA, which you heard about, and of course, physics and all that kind of good stuff. But it all works. It's as you would expect. We improved the filtering quality. So one of the things which is pretty common, I'm sure you guys have seen, is that shadows, a lot of times the edges can look blocky, jagged, ragged edges. There's lots of ways to improve that. You can use jittered sampling, faint your filter kernels, and things like that. So one of the things we implemented was bicubic filtering, which is a higher order filter. It's implemented in a vendor agnostic way. It works in us, works in ATI. You can see that both us and ATI, there's a performance hit. It's pretty similar, frankly, between the two of us. But it just improves the image quality, and probably the best way to see it is here. Here's the console, or the version of the game that would have happened without NVIDIA, and you get the stair-steppy jagged effect on the shadows. And here's bicubic. Much smoother, right? It's an option. You don't have to turn it on, but it's one of those enhancements we made, which makes the PC better than the console. One of the other things that's just kind of obvious is that the PC's performance capabilities are well beyond that of the consoles, right? Considerably further. So a lot of optimizations and image quality improvements you can make in the PC. They wouldn't have been practical on the console, but you might, if you've got all this horsepower, you should use it for something that's make the PC experience better. So here's an example of us just making the PC experience better. Instead of me talking, why don't we have Mark talk a little bit about the Dark Void experience, since he was the evangelist that drove that.
Cool. So you guys saw a little demo earlier for Dark Void. I just wanted to highlight